How are you guys? Welcome back to my YouTube channel. We're dealing with ventilation and 6-foot mechanics. Okay, do not forget to subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. So, right, we're given 4.3. Question reads as follow. A fan duct. We're given a fan duct. It has fan duct. Fan extract. Okay, it's a fan extract of 9,2 cubic meters per second. This is equal to Q. It's a rate of flow through a cross-sectional square duct. You see, this is a square duct. They've told us that means this is a square duct. We'll focus here. We are given that it's a square duct. That cross-section, it's a square duct which is 50 meter long. That means we have length, there is 50 meter, and the pressure, we've given a pressure there, is required to overcome the friction of the duct. To use K in Eltikison's formula of 0 formula S is 0,003. That is the friction factor you have given, which is 0,03, and calculate the cross-section dimensions of the duct, which is DC duct is this one. Remember, they said they've given a square duct. Now they want the dimensions of, they want the cross-sectional dimensions of the duct. They say the duct is what? It's a square duct here. That means you want these dimensions, right? It's fine there. We want those dimensions. That means we know, because it's the same, it's a square duct. If we can have B, that means we'll already have B all over, will be B throughout it, because it's a square, right? It's a square duct, isn't it? So yeah, so we have that, right? So I can say we know the formula that we're supposed to use. It says pressure, it's equal to K rubbing surface velocity squared over area. We're supposed to use this formula. It's a main formula, it's a major formula for the according to this is the duct. We'll use it when we are dealing with ducts. So I can start by finding the rubbing surface. That means that S rubbing surface, can get the rubbing surface, which is, I know that I can say S is a rubbing surface. This is equal to perimeter multiplied by length. Always will be perimeter multiplied by length, right? The perimeter, you've given a square duct. Remember, we'll focus on the square duct, will be the perimeter of the duct, but they've given us the square duct. So the perimeter of the square will add, when is the perimeter, we add all the sides, will be p plus this p plus this p plus this p, will have p. 4 p's will have what? When you sum them, will have 4p, right? We'll have 4 p's. That means here we'll have 4p multiplied by the length. The length is 50. They've given us there, as you can see. So you'll multiply this by 50, then 4 multiplied by 50 is 200. Then we have B here. This is the rubbing surface in terms of B. That is what we have in terms of B. We must know this is measured in meter squared. Because why is measured in meter squared? Because perimeter is measured in meter the length is measured in meter. When you multiply, this will result as meter squared, right? Yeah. This is measured in meter squared. Okay, you can include it as SI units if you want, like this. We have this then. Okay, what about the velocity? You can find now the velocity, but it's v squared, as you can see there. So what do we know about velocity? Okay, can get velocity. We are not given a velocity on the question, but we know that q, the rate of flow, its area multiplied by velocity, because we've given q here, a rate of flow is 9.2 cubic meters per second. So can take advantage of that. We have q is equal to q is equal to area multiplied by velocity. So we can make v the subject, which will be equal to q multiplied by area, that which we've given, that is 9.2. The area, it's a square, right? It's a square duct. Since it's a square, will be p squared. Remember, here the area will be p squared. The area will be height multiplied by width. So you see height here is what is b multiplied by b, will be equal to b squared, isn't it? So yeah, this is an area. We have the area there is b squared. Here we have a b squared, right? So this is a squared, right? Yeah, we have calculated what a velocity, but here we have, if you can check, that is only v, but here we have v squared, but us, we have calculated v only. So for us to obtain we have calculated v. For us to obtain v squared, we want to obtain v squared, right? We know v is this, is 9.2 all over b squared, right? We can square this because we have a square there, right? When you square this, will come there, we'll have 9.2 squared over b multiplied by 2. This will result as 4, right? So that is what we'll have. We have here is 2, 9.2 raised to the power of 2. Here we'll have power 4. This will be what, v squared, right? So see, this is what we have. Yes, we have this area, obvious. We have the area is b squared. K we are given, so the pressure, we are also given the pressure. So we know that PR is equal to K, yeah, right, rubbing surface multiplied by v squared over area. We have K, which is 0.003. We have been given that. Rubbing surface, we got 200b multiplied by v squared here. Rubbing surface here, we got 200b. We're given K, which is 0.003. See, 0.003 multiplied by, now we have this, as you can see there, that should be we have 9. We multiply, sure this is a multiplication, right? We'll multiply this by 9, comma 2 squared, right, multiply this by over b to the power of 4 over b to the power of what, to the power of 4. Yeah, we've substituted, but all over what area. We'll divide all of these by area. For to make this easy, we can just do like this. Okay, we can just take it like this. If you know your math, area is a squared. These two will multiply, will be what, b6. The b's are the same. We add the exponent, will be b to the power of 6. So you can replace this here. On the denominator we can have b to the power of 6. All right, we have the pressure here. Remember all of this is equal to what, to the pressure here. Pressure is 200 is what we have seen there. So this is math, or multiply there. That 200 by b will have 200 b to the power of 6, and have this will be equal to 0,003 multiplied by 200b times 9,2 squared. Yeah, so we have b here. You see this side will cancel with one of the b there. That means we'll have 200 b to the power of 5. That is maths 0,003 times 200, right, times 9,2 squared. In actual fact, I have b to the side, also this side I have b. Can simply divide that b, you see. So I will left with b to the power of 5 and 0,003 multiplied by 9,2 squared. Then I multiply these two. If you multiply these two, supposed to get that 0,003 multiplied by 9,2 raised to the power of 2. Supposed to get that b to the power of 5 must be equal to 0,254. Right, then I take root to the power root 5 both sides. Right, this will cancel that. I'll left with b. Then I punch this root 5 here. Say shift root 5. You must press a shift root 5. Right, then you put 0,254. right, you will get this is equal to 0,76. right, you have 2, so and so on. But since it's a final answer, we can just raise the just make to 3 decimal place. So we'll take this part, right, will be 0,76 but you let us make it be in millimeter. You multiply by 1000, then you'll have your answer in millimeter. Your p will be 760 millimeter. This is our dimension. Yeah, because of the duct, because they wanted us to calculate the dimension of the duct, which is is P. We have this P here, the dimension of the duct. So since it's a square, it will be the same throughout. We got the P. So yeah, this is necessary step that you're supposed to take. Thank you guys for your time. Do not forget to subscribe to my video and share to your fellow classmates. Thank you.